If we jump to calculation number 1, the important part of doing a mass-to-mass problem is that you need a balanced equation, so we know our mole-to-mole ratios. So these are a balancing equation, double replacement reaction, which we're used to, but it's slightly different because we have these hydrates attached to them, right? And the hydrates are going to be a little confusing. So as you can see, I just underlined all of the different waters, but those waters are attached to the compound. So for example, if for some reason I needed to put a 2 in here, that 2 would distribute to the zinc, it would distribute to the acetate, and it would distribute to the 2 waters. So that'd be 2 times 2, so you get 4 H2Os. And eventually the H2Os have to balance on both sides of the equation. So let's work together to balance that out. I'm going to leave the waters for later because I've got a water here by itself, so I'm going to try to balance everything else out. But if you notice, I have 2 acetates over here and only 1 acetate over here. So I'm going to put a 2 there, and by doing that, my acetates are now balanced. But here's the problem. When I do that, I've got 3 sodiums over here and now 2 acetates over here. That's not going to work out because 3 and 2 don't go into each other very easily. It looks like they're going to need to be 6. So that means I'm going to have to back up a little bit here. So I'm going to erase. And let's try with the sodiums at 6 and see if that works out for us. So to do that, let's see, I'm going to put a 2 in front to give me 6 sodiums and a 6 in front of here to give me 6 sodiums. Now by doing that, I created 6 acetates as well, C2H3O2. But I already have 2 here, so I think I'm going to need to drop a 3 there to give me 3 times 2, which will give me 6 acetates. Okay, so right now, let's just keep track. Sodiums are balanced, and so is acetate, C2H3O2. Next, let's do zincs. There's 3 zincs here. There's 3 zincs there, so my zincs are balanced. What about my phosphate? I've got 2 phosphates over here. The 2 and the phosphate, ooh, good. Those balance out. So now my phosphate is good. The only thing left to do now is figure out if my waters are balanced. So let me clean this up a little bit and then let's work on our waters. All right, so let's do that. Let's see. Let me get a color here. 2 times 12 is 24 waters. Okay, so we've got 24 waters there, and 3 times 2 gives me 6 waters. So in all, on this side of the balanced equation, we have 30 waters. All right, so we got to find a way to get 30 waters on the other side. Well, right here I have 4 waters, and that's it. I only have 4 waters over here. This 6 can only distribute to the sodium and the acetate. So I guess the question is, how many do I need over here to give me 30? I'm going to need 26. So 4 plus 26 will give me 30. So this means I'm going to put 26 right there. Perfect. So it looks like this balanced out, crazy, right, is going to be a 2, 3, 1, 6, and 26. Now this will be important because when we do our math equation, we want to convert from zinc phosphate is the product or the precipitate we gathered. So think about it. Let me highlight that. This one right here is going to be our precipitate, and we compared it to what we massed out, which was the zinc acetate, which was this one to start. So it looks like we're going to be going from a 3-to-1 ratio. So that'll be good to know, especially in calculation number 2, when we figure out a mass A to mass B calculation. So let's move on to that. When we look at calculation number 2, I just want to help you get started. You're going to be doing a mass A to mass B calculation. So you want to figure out the predicted or theoretical amount of precipitate that we should have gotten. So our precipitate, that white substance that we strained and dried overnight in that, is called zinc phosphate, and it has 4 waters attached to it. You want to know how much that should have made from the original 2.9 grams of the zinc acetate. So you're going to start with mass of A and eventually go over to mass of B. And you can use your mole map to help you with that. But remember that the A is your zinc acetate, C2H3O2, and it has 2 waters attached to it. So when you eventually need to find the molar mass of this, you're going to need to take zinc acetate plus 2 whole waters for the mass. The same thing is going to hold true for your mass B object, which is going to be the precipitate zinc phosphate. Zinc phosphate, oops, there's 2, not 3 there, has 4 waters attached to it. So that means when you find the molar mass, you're going to need to take 3 zincs, 2 phosphates, 8 oxygens, plus 4 entire waters added up to give you the total molar mass. Then from there, you can do your calculation where you're going to go from mass A to mole A, from mole A to mole B, and then finally from mole B to mass of B. So in the end, as you know, you're going to use molar mass, so that's the big part that sometimes troubles people, is how do you add up this entire mass? It tells you right in the directions you should add in the mass of all waters in the compounds as well, but now you know. What we're starting with is our zinc acetate, that's our A object, and zinc phosphate is our B object. Remember, this answer will give you your calculated or predicted value. That is what math will tell you we should have gotten. We will then compare that to what you actually got in the lab, which if I remember is about 4.09 grams of the substance. We're gonna see how close we are between reality and math. All right, science fam, that's it for me. Best of luck with all of your work. Make sure you show your work in calculations and work together to make sure that you can understand the whole main idea of this lab, which is that we're trying to figure out what we did in the lab, how much we got at the end of the precipitate, how close are we to that mass to what the math or the stoichiometry predicted. Is it even right? We shall see. Be well.